Hey, what's up, everybody? I'd like to welcome you to another audio programming for beginners tutorial. I say another, this is the first one. But this is actually an updated version of a earlier video that I did. And the reason that I'm doing this updated version is because some people have left some feedback for me that my voice was too low on the first version. It was one of the first videos I did. So I just decided to do this updated version for you guys. And, it's going to cover the same subjects basically. So this is the first audio programming for beginners tutorial, and what we're going to talk about today are some very basic digital signal processing concepts, or DSP concepts for short, and just try to break those down to give you a better understanding of what happens when it comes to how we get sound into a computer and how we get sound back out of a computer. Now, these processes that I'm going to talk about, I'm going to really simplify because this is for beginners. But I want to let you know up front that this is, that these processes are things that involve a few more steps than what I'm going to cover in this tutorial. And that, some people, they devote their kind of life's work to these processes and theories involving digital signal processing and sampling rate, bit depth, and so on and so forth. But I just want to give you a general overview so that we can get into building plugins. Okay, now you need to know these things in order to build any sort of audio application or plugin. And the reason is because you just have to know how to get sound into a computer and out of a computer and exactly kind of how that happens. So if you wanted to build a distortion or a reverb, you have to be aware of what a sound is doing at a particular point and what sort of things that you need to do in order to produce the effect that you desire. Okay, so we're going to go ahead and move into things. At the moment I have Ableton open, okay, just to give you a general overview of the things we'll be explaining today. First thing that I'll show you is if you go down to the bottom left here, we have this squiggly line. I'm sure most of you know that it's a waveform, okay? What this is doing is this is going between values of a maximum of +1 and -1, okay? With +1 being up here at the top, -1 being down at the bottom, okay? Now, a lot of us don't really think about what this wave actually means. We know that it has something to do with the sound that we actually hear, but we don't actually really think about what it represents, okay? And the representation that we have here is actually where your speakers need to be at a particular point in time, okay? So this is actually the vibration that your speaker needs to make to actually reproduce the sound that you would be hearing in your headphones or out of your speakers, okay? Because that's all sound is. Sound is a vibration, okay? So, if you think about the sound of my voice, it's I'm making vibrations with my vocal cords, and those are going through the air into the microphone. It's getting processed into the computer through a process called analog to digital conversion. Okay. Then once it's represented within the computer, then it comes back out through what's a process is called digital to audio conversion. Okay. And then it's going back. The vibrations are passing back out through the speakers, and then into your ear. And then your ear is kind of like a speaker. It's catching those reflections and refractions, I think they call them. So your eardrum is vibrating, and that's what's producing the sound that you recognize as my voice. Okay, so this graphic here is an actual visual representation of that kind of that sound. Okay, not the sound of my voice, but a sound. Okay. So we're going to break down the subject of exactly how these sounds get into the computer and back out of the computer, okay? And we need to know about a couple terms in order to be able to discuss this. First thing that we need to know about is this thing called sample rate. Now, if you've ever worked in a digital audio workstation such as Ableton or Logic, then you have probably come across this and you may have wondered, well, what does that actually mean? Okay, 44,100 as the sample rate. What does the 44,100 represent? Okay, I'm going to explain that to you. Okay, there's another concept here I think we go to the export settings here, and you have this concept of what's called bit depth. Okay, so you may have seen it: 16-bit, 24-bit. If you're talking about 80s video games, you might be talking about 8-bit depth. Okay, what does that mean? We're going to talk about that today. Okay, so I'm going to go ahead and close out Ableton here and go to a digital whiteboard. Now, I want to let you know up front that my writing on this digital whiteboard is really terrible, but I'm hoping that I can get the explanation across and that you'll overlook any sort of shortcomings that I have with the whiteboard. Okay, so as I said before, we're going to talk about sampling rate. Okay, let me see if I can get this working. Been having some issues with this. Let me just refresh quick. Sorry about this. This always seems to happen when I record, but it never seems to happen when I... Okay, here we go. Sampling rate. Okay, and we said that was 44,100. Okay. The 44,100 actually means 44,100 times a second, every second. Okay. Now, if we go back to try to recreate kind of a drawing, sort of like what you saw with that kick drum wave that we were looking at in Ableton, okay? And you have this line. This line represents 0, so that's kind of where when your speaker's in a neutral position, it's not actually even doing, it's not making any sort of sound, any sort of vibration. So what we're going to do is discuss this process of what we call analog to digital conversion, okay? And this is done through a process of sampling, okay? So what happens is when I'm speaking through this microphone, the computer is actually sampling my voice, okay? And it's attributing values to the to my voice at certain points in time, okay? Now, how many times in 1 second is it giving my voice or the wave of my voice a value? Okay, that's how we get to 44,100. So 44,100 times every second, the computer is taking a sample of my voice. Okay, and it's just doing it just like this. Let's just say that this is 1 second. Okay. Okay. Let's just say that this line represents 1 second in time. And hopefully I can draw this. Okay. And what we're doing here is we're actually just drawing these dots, and these dots represent value markers that the computer is taking at various points in time. Now in a computer it would be doing this 44,100 times in a second. Okay? So we could just like look at this value, and this would be 0 out of 44,100. Okay, and that second value would be 1 out of 44,100. The third value would be 2 out of 44,100. Okay, and so that's all that's saying is that, let me just erase that. So what it's and what it's doing is taking a sample of where my voice is. Then it's waiting until the next 44,100th of a second, and then it's taking another sample of where my voice is. And it's doing that 44,100 times a second, and that's how we're getting to the sampling rate. Now, what happens is that it's, so just to give you an idea of how that happens, so it's taking the sample of my voice, and then it's holding it until the next 44,100th of a second, and then it's taking another sample, and it's doing this throughout the signal. Okay, and then it's producing something like this. Okay, now once it's done this, as you can see, it's kind of a rough wave, okay, but if it's doing it 44,100 times in a second, that's quite a few values that it's taking. And then what it does afterwards is this process of interpolation, where it kind of takes and it smooths these values out, and that's how you get that smooth wave that you see, as we saw in the sampler in Ableton earlier. Okay, so that's how that happens, and that's how we get that number 44,100. In terms of the sample rate. Okay, now let's just talk about these values. So we've talked about how we're getting these values kind of on the x-axis, okay, going from left to right. Okay, what about these values? Hopefully my pen's not going to break on me. Please don't. What's going on? What's going on with the pen? Oh no, it's going haywire. All right. Okay, I think I'm okay now. Okay. I'm going to erase all this. Okay, so we have a wave. Okay, let's just say this is my voice. Let's just say this is 1 second. Okay, so we've talked about what happens on the x-axis. 44,100 times a second, every second, is taking values. Okay, and then it's basically drawing a connection between those values, and that's how we're getting the wave. Okay, but what about these values on the y-axis? Okay, how many of these values do we have to actually work with, and how do those determine how well our sound is represented? Okay, and that's where we get into this concept called bit depth. Okay. Now, we have a number that in Ableton of 16, okay? Can be increased or decreased, okay? But I usually work with 16 bit depth, okay? Now, does that mean that I have 16 places between +1 and -1 that I can put a value at? No, it means that I have 2 to the 16. Okay, pen's going crazy again. 1 second. 2 to the 16th power. 2 to the 16th power. Ah, this is getting so crazy. 2 to the 16th power. Okay, let me write that again. 2 to the 16th power. Okay, of values that we can represent between +1 and -1. Okay, and that, I believe, if my memory serves me correctly, is 65,536 values that we can represent between +1 and -1. Okay, it's quite a few. So that's approximately 34,000 values that we could represent from 0 to 1, and about 34,000 more or less that we could represent between -1 and 0. Okay, so that's quite a bit. Okay, so if you're smart, you might be thinking, okay, well, let's just say we took this value, that this was like a value that our voice was sampled. Okay, let's just say, for instance, that it wasn't one of those 65,536 values that were chosen out that we could put that value into. What do we do then? Well, this is another process called quantization. Okay. Quantization. And I'll review all this at the end. Okay. Quantization just means that, okay, we've taken this value and it doesn't quite go in one of the 65,536 values that we can do between +1 and -1. So what we do is we just kind of round it up or round it down to the nearest value, okay? So that it fits in one of those 65,536 places, okay? And that is pretty much how that's pretty much how sound is gets from, you know, something that's like my voice that's traveling through air into a value that's read into that can be readable by a computer through this process. Because some of you might be thinking, well, why can't we just sample just all the time. Why do we have to do it a limited time of 44,100 times a second, or 96,000 times a second if we wanted to be operate at a higher sampling rate? And the answer is because if we were trying to, it's impossible to take a sample at every point, so to speak. There's no computer that will probably ever be powerful enough to be able to just sample it the way that you're hearing it. You'd be hearing my voice if you're hearing it, actually in person, as opposed to over a computer. Now, our human brains can't, tell the difference, because we just kind of intuitively make connections. But that's the reason why some people think that vinyl sounds better than CD or a digital representation of a song. And the reason is because vinyl is analog, okay? And CD or wave, anything like that, is that's sampled, okay, 44,100 times a second. And that's how you get to the the perceived difference that some people feel that they hear. Okay, so let's complete by just saying this. Okay, so going back to this concept of the sampling rate, 44,100. Okay, sorry, 44,100. Okay, so sampling rate. Okay. Why is it 44,100? Why do we pick this number? Okay, well, we have a theory. It's called the Nyquist. Okay, it's actually a theorem. There's more than one theory. But the Nyquist, normally when audio developers talk about the Nyquist, okay, they're talking about a specific thing, okay, which is that the Nyquist theory basically states that if we have a sound, okay, that the maximum frequency that can be represented is going to be twice the maximum sampling rate, okay? Now, some of you might not really understand what I mean by that, okay, but let me break it down for you. Okay, humans can hear between a frequency of 20 hertz to 20,000 hertz. Okay, that's the basic range of human hearing. Okay, most of us, especially me, can't hear all the way up to 20,000 hertz, but that is the understood range of human hearing. Now, the Nyquist theory states that the maximum frequency that can be represented in a domain, if we were sampling a sound, is half of the sampling rate. Okay, so our sampling rate is 44,100. Okay, and the Nyquist says that the maximum frequency that can be represented is half of the sampling rate, okay, which would give us 22,050, okay? And so we can see that this is the maximum frequency that we can represent with a sampling rate of 44,100 hertz, okay? 22,050 hertz is the maximum, is the highest frequency that we could represent. So we can see kind of how we got to that 44,100 hertz. Okay, that's the least. That's the sampling rate that we would need, at least a sampling rate of 44,100 hertz to be able to represent the range of human hearing, plus a little change that you get from there's some like low pass filtering that actually happens. I don't want to get into all that, but there's a little bit of headway off of this 22,050 hertz, where they're basically able to low pass filter any higher sounds that might alias onto that onto the frequencies that we can hear, and that's why we have 22,050 hertz as and 44,100 hertz as our sampling rate, rather than just something that's like, let's say 40,000. Okay, like you would say, well, why isn't it 40,000? You know, because the maximum range of human hearing is 20,000. Why isn't the sampling rate 40,000? Well, there are a couple of reasons for that, but the main reason is that when you get a song, or when you get a representation of my, let's just say, my voice, it's sampling at all frequencies. Okay, it's sampling at because there are obviously frequencies that are happening that are above the range of human hearing. Okay, but what happens is that our sound card actually filters out all of the frequencies that we don't need. In this case, the frequencies above 22,050 hertz. Okay. And then what it does is it gets rid of all those higher frequencies, so that we don't hear any unwanted frequencies in our range of human hearing that might be represented through aliasing. Okay, which is a subject that we'll cover for the next tutorial. And that's a great place for me to end it. And I hope you enjoyed this tutorial, and I will see you next time.